Hello, this video demonstration shows Group 93's improvements to the Star Search simulation system, implemented during Georgia Tech's Spring 2020 semester, course CS 6310, Assignment 6. During Assignment 6, we've made 3 distinct improvements to the simulation system. First, we've added a graphical user interface. The GUI allows users to visualize the simulation runs as they are happening and gives them control over the pace of playback. The GUI includes 2 playback modes: manual mode, which allows the user to step through the simulation run one step at a time, and automatic mode, which allows the user to watch the simulation runs play continuously with variable speed control. Second, we have given the user the ability to rewind and replay the simulation runs. The user can either reverse the simulation run one action at a time, or rewind continuously for any number of actions up to the beginning of the run. The ability to rewind gives the user more insight into how previous drone actions affect future simulation states and eliminates the need to run simulations from start to finish whenever any review is needed. Third, we have added simulation state data persistence, allowing the user to resume the simulation run from the previous state the next time the application is opened. This allows the user to spend as much time as needed on simulation run and drone strategy analysis without worry of losing their place if they need to close the application. With that being said, we will now go through the demonstration of the improvements. First, we double-click the Star Search app icon to launch the application. We are then prompted with a choice to load a save scenario or start a new scenario. We'll start with a new scenario first. As you can see, we get a nice graphical user interface. Here, we can see the display grid representing the space region. The drones are shown with their orientations. The GUI also allows us to differentiate between known and unknown squares. For now, we can only see the drones because at the beginning of the simulation run, the drones only know the drone locations. However, if we want to see the whole space region regardless of known or unknown status, we can simply toggle the Show Unknown Squares checkbox. Now we can see the whole space region, including suns and star fields. Moving on, here we have some general simulation state information. Here we have total number of squares in the space region, number of explored squares and total safe explorable squares in the space region, current number of completed turns and total turns allowed in the simulation run, active drones and total drones, the current action, which shows that it's not available because no drone has executed an action yet, the next drone that will be allowed to execute an action, and the result of the previously executed action, which again is not yet available. In terms of control buttons and widgets, here we have step forward and step backward buttons, play forward and rewind buttons, a pause button, playback speed control slider, simulation state save button, and stop and exit button. Now that we have a good overview of the GUI components, let's take a look at some of the features in action. First, we have our step forward and step backward buttons. As you can see, the simulation state information is updating as we step backward and forward through the simulation run, including graphics in the display grid and state information in the panel to the right. Below, we can see the outcome of our action. Now that we've seen a few simulation steps, you might have noticed the drone border colors changing. As the legend below the space region shows, the drone with the red border is the one that has just executed the action, and the drone with the green border is the next drone that will be allowed to execute an action. Also, you can see that as the drones execute some scan and thrust actions, the known space region becomes more and more visible. In addition to single-step playback, we've included an automatic continuous playback mode. We can start automatic playback mode by clicking the play button here, rewind by clicking the rewind button here, play again by hitting the play button, pause, play again, adjust the speed, slower, faster, pause, rewind, here we can see a dialog box letting know we've reached the beginning of the simulation run because of rewind mode. Similarly, if we play to the end of the simulation run, we'll get the same dialog box indicating that we've reached the end of the run. And as you can see, we get the dialog box. We do not close automatically at the end of the run in case the user would like to review some actions like so. Now that we've seen much of the pace control functionality, let's take a look at the simulation state save and restore functionality. Take note that we've explored 21 squares and have completed 8 turns, with drone 1 being next. So we'll save the simulation state by clicking this icon, My New Saved State. Close by hitting the stop and exit button. We get a summary showing the total size of the space region, safe squares containing stars, explored squares, and number of completed turns, which, as you remember, was 8. At this point, the simulation application is completely closed, and we can launch it again by double-clicking the icon. This time, we'll select Load Save Scenario and select our file from before, My New Saved State. As you can see, we pick up where we left off with 21 explored squares, 8 completed turns, with drone number 1 being next. And now, we can play the simulation run to the end of the run. Again, we get the dialog box saying we've reached the end of the simulation run, and we can click OK and click Stop and Exit. Now we can see that we've explored all 25 safe squares in only 11 total turns. In conclusion, we have added some nice features that work together to enhance the user's ability to evaluate simulation runs and drone strategies. The improvements begin with the graphical user interface, allowing us to visualize the simulation runs. The rewind, replay, and pace control gives us the ability to analyze drone strategies in more detail, and the data persistence allows us to close the software without losing our place in the simulation run when we're ready to return to the application. Once again, we are Group 93, Georgia Tech Spring Semester Course CS 6310, Assignment 6. Thanks for watching.